Okay, question 8 is a pure question on number pattern, and sometimes I know it can be quite difficult. So other than common difference, right, sometimes there are more than that. So I think this question illustrates the kind that is more than just a common difference. So if you look at the pattern, we are adding numbers. So we are adding numbers, and the patterns kind of lies with the 2, 3, 4 here. So if you explore a little bit, right, the 2, because you're adding 2 numbers, you add 2 numbers. So this somehow look like, and here you're adding 3 numbers. So that's why we become a 3 here. So here you add 4 numbers. So it seems like that is the pattern. So how many numbers you add is the one that determine this column. So this column is kind of like related to how many numbers you're adding. So that's why if you have this, if you realize the pattern, right? So here you're adding 6 numbers. You count 1, 2, 3, 4, 5, 6. So it should be 3 times 6 squared. Okay, so that means, right, the pattern lies with how many numbers you're adding. So in a way, if I work backwards for this situation, okay, you can do like algebra. You can solve like algebra, like 3y squared equal to this. So eventually you got a 13. So what does this 13 say? That means, right, you are actually adding up 13 numbers. Three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you're adding up 13 number. So you got to go in an organized manner. So the number is like +6. So you got to do a +6, +6. So every number that you're adding is +6. So you just have to do it manually, and you are adding up 13 numbers. So that means, right, this is your X. So you got to see in this way. So this one is really not common difference. So you must realize there's a pattern. This one is even worse. Okay, this one is even worse. Okay, I presume, right, all of you will be okay to fill up the table. I'm quite sure you can fill up the table. The problem is, if I fill up the table already and I realize it's not a common difference. If you explore, right, you're not going to get a common difference. So if it's not going to be a common difference, I actually wouldn't know what to do, correct? There's no formula. So usually I will explore n squared. So I will explore an extra column. So this is n. I will explore an n square column. That means I square all the numbers here. Then I got to observe, is there any pattern or not? Okay, is there any pattern? So if you slowly observe, right, okay, can you see? If you add them up, you divide by 2, it gives you this. If you add them up, you divide by 2, it gives you this. So because of this, okay, you can carry on and just make sure that it matches with all of them. So here, that's how I know that is n squared plus n divided by 2. Okay, so if it's not a common difference, I will usually explore n square pattern. Okay, then the next one is also not common difference. So I'm going to explore with the n square. I make use of the n square. So if you look right, this column is my n square. And the other column looks like a multiple of 3. So that's how I explore. And if you look carefully, right, this part is the column of n. So my formula here for P is n squared plus 3n. Okay, no fraction. N squared plus 3n. So it's very important you get these two. If you can get these two right, the subsequent part is going to be so easy. So which figure has a parameter of 88? So you are doing a quadratic equation. Okay, what is the area? So that depends on what is the n that you have found. And then you can try to solve for the area. So everything rely on the formula. So this is a situation where you don't get common difference. You might need to explore an extra column of n square, or sometimes maybe even n cube. Okay, it may or may not be. So n square is a common one that I will usually do. So hopefully this clarifies the one on question 8.